here in second year lab of Department of Physics of IIT Kharagpur. So, we will show the experimental setup for measuring the Young modulus of a bar or beam. So, the shape of the material we have taken in form of bar. So, this here you can see this is the bar. So, this Young modulus will find out of the material of this bar. So, it is basically Young modulus is independent of the shape of the material. So, you can take in shape of wire, means cylindrical form, you can take also in form of this bar. So, there are two methods as I mentioned, this one is Charles method, there we take the material in form of wire, and this is the flexor method. In this method we take the material in form of bar. So, this is a bar basically, and its length is around 1 meter, 100 centimeter. So, it has length say L, capital L, and it has breadth. So, this is the breadth, and it has thickness. So, this is the thickness D, breadth B, and length is L. Okay. So, in flexor method what we do? We select a certain length of the bar. This bar is kept on the sharp edge, knife edge of two knife edge. So, here these two knife edge, one and this another one. Okay. So, on this knife edge we keep the bar symmetrically, basically symmetrically. So, this experiment will repeat for 2 to 3 length. So, we can select the length just moving this knife edge. So, that I can show that we can move it. So, basically just you have to loosen it, and yes, then you can move and adjust the length. Okay. So, initially say I will select the length say 80 centimeter. So, I need to measure the length this meter scale or centimeter scale. So, I have centimeter scale. So, here this 100 is basically 100 millimeter, 10 centimeter, this 20 centimeter, 300 millimeter means 30 centimeter. So, between these two knife edge, I will here I have put as say this edge is at 10 centimeter, this other edge if it is 90 centimeter, then it will be 80 centimeter. So, it is slightly less than 80 centimeter. So, I have to just adjust the length moving this one knife edge. So, I put it at 90 centimeter, and this other end I will put at 10 centimeter. So, 90 minus 10. So, this length is now 80 centimeter. So, between these two knife edge the distance is 80 centimeter. So, now this effective length of this bar is 80 centimeter for our experiment. So, I will put it symmetrically. Okay. So, first we have to choose length. So, that I have chosen 80 centimeter using the meter scale. The least count of this meter scale is basically 1 millimeter. So, that we have to note down. So, that we have to note down. So, this scale have the least count is 1 millimeter, means 0.1 centimeter. Okay. So, next we need to know the breadth of this bar. So, for that we will use slide calipers, we will use slide calipers. Why we will use slide calipers? Why not we will use the this meter scale? Because this in this case we have scope to use a better least count instrument or tools, because for measuring the length I cannot use the slide calipers, because this length is very large and appropriate tools is a meter scale. So, that is why I have used, and also this least count of meter scale 1 millimeter compared to the length 80 centimeter. So, this error effective error will be very small over this length. Okay. So, for this for measuring the breadth of this bar we will use slide calipers. So, I have discussed about the slide calipers. So, first you have to find out the least count of the slide calipers, right. So, how to find out that I have told you earlier in earlier class. So, just you measure, then you measure the breadth of this bar at least at 3 to 4 points. So, at this point you measure the breadth, and then you measure the breadth at this at the middle point, and then you measure the breadth at this point. Okay. So, then you note down this all 3 readings, and from there you have to take basically okay. So, I think it was just opposite direction I showed you, but it is basically if I show you the front side. So, you can see the scale. Okay. So, here you should take the reading for this breadth at this position, okay, and then as I told in middle position, and then this another end you can take this reading. Okay. So, how to take reading, that already you know, I have discussed. So, using the slide calipers we have to find out the breadth of this bar. Okay. Next we have to find out the thickness of this bar, So, for that again you can use the slide calipers, but we will prefer to use screw gauge, because screw gauge have better least count. Slide calipers has least count is 0.01 centimeter, and screw gauge has least count 0.001 centimeter. Okay. So, here I have scope to use this screw gauge. So, that is why I will prefer to use the screw gauge. Again the screw gauge, about screw gauge I discuss. So, how to find out the least count of the screw gauge. So, it has linear scale as well as circular scale. So, just use your knowledge as you learn from earlier class. So, find out the thickness or depth of this bar. Again you take 3-4 reading at different places. Okay. So, at these places what is the reading you find out, how to find out, that I have discussed. Second, you take this another position, you take this at another position, and then also in third position or fourth position. Okay. So, this way you measure the length, breadth and depth for this bar. Okay. And so, I have taken already this reading for this one. So, that I will show later on. and discuss how to analyze this data and calculate the Young modulus. Okay. So, now next job is, as you know, this working formula, as I told you, that for this Young modulus, working formula is y equal to g L cube, means length cube, divided by 4 b d cube, then m by L. So, already we have measured L, okay, and then we have measured b and also d. Okay. So, there is again reason to use this screw gauge for measuring d, because this power of d is 3. So, this error will be basically in measurement of this d is 3 times of the least count. Okay. So, whenever any parameter have higher power, so you have to be careful for measuring that parameter, because this error will be multiplied with this power. Okay. So, now next measurement we have to do m by L. What is m and what is L? Basically, in flexion method we here just will. So, this one we have to put at the middle, this one we have to put at the middle. Okay. So, these are basically indicators for measuring the diffraction, that is small l, whatever I showed. So, we will just load or apply different mass on it, means, so this force, gravitational force will be mg. So, for different gravitational force, there will be diffraction of this bar, and that diffraction we have to measure. Okay. So, this is the main task of this experiment. So, we will apply different mass, and for that different mass, what is the diffraction, that we have to find out. So, this one we have to put exactly in middle of this bar, means between this effective length. So, I have to again use the scale, it was 80 centimeters. So, I have to find out this basically position of 40. So, it is a 500. So, yes, in this case it is the 500, because 100 I have taken at one edge. So, 900 is another edge. So, middle position will be at 500 millimeter or 50 micrometers. So, approximately, not approximately, accurately one can find out. So, this position will be at the middle of the bar. Okay. This position will be at the middle of the bar. So, I think I have to place properly, so that it should be free. Now, I have to measure the diffraction for different mass. So, for measuring diffraction, we will use this instrument. This is basically is travelling microscope. It is a travelling microscope, means this microscope, this one, it can travel vertically, or also it can travel horizontally. So, just I will show you. I think I have to loosen it, and then this basically you can just move it, and you can measure the, basically here there is a scale, here one scale is there, okay, horizontal scale, and with this scale there is a vernier scale. Okay. So, this is just like slide calipers. Okay. So, this is the horizontal scale. Also we have vertical scale. We have vertical scale here. So, for vertical movement you can just loosen this screw and take your position, and then tighten it. So, here there is a I will show you, I think here there is a vertical scale, here there is a vertical scale, okay. Again this linear scale and this another main scale and this vernier scale. Okay. So, both of the scale have again like these vernier slide calipers, you have to find out the least count, vernier constant, and here you can see here this total division in vernier scale, there are 50 divisions, there are 50 smallest divisions, and if you see this main scale, one smallest main scale in this case is it is 0.5 millimeter. So, your vernier constant will be 0.5 millimeter divided by 50 division. So, it will be 0.01 millimeter, means 0 I think 0.5 divided by 50. So, it is 1 by 100, 1 by 100. Okay. So, it is 0.001 centimeter. Okay. So, whatever the screw gauge I told this, in our screw gauge we have least count is 0.001 centimeter. So, this scale also have the same least count. So, that means it has better least count than the than our slide calipers. So, whatever slide calipers I showed you, probably it is the better one. I think these slide calipers have the vernier constant of 0.002 centimeters. Okay. So, so even this one is better least count, having better least count, because it is 0.001 centimeter. Okay. So, this so using this travelling microscope, we will find out, we will measure the depression of this cantilever. Okay. So, for measuring this, what we have to do, first we have to focus the indicator. Here there is a indicator, here there is a one cross point. So, we will measure the depression versus load, means we will apply different weight, and for that what is the depression that we will measure. So, for that here we have arrangement, this here one cross you can see. Okay. So, we will focus our microscope at this point. Okay. So, then for that, so we have to focus this microscope at this point. So, it is already we have kept in focus. Okay. So, there is a crosswire in microscope eyepiece. So, that crosswire will coincide with that other this cross point. So, that I have kept it, Okay. So, then you have to take this reading, what is the reading? So, that is the initial reading we will take here from yes. So, here we have vernier scale, then 0 of the vernier scale, basically 0 of the vernier scale is here, and 0 of the vernier scale is here, yes, and it is the this main scale reading I have to take, and this is a 9, and then it is between 9 and 10. So, then you have to see the this yes. So, you have to count the division. So, I can see here approximately it is 9, yes, I think yeah, it is 9.2, and then yeah, it is around 9.2. So, you have to take this reading carefully and find out the vernier, this which vernier coincide with the main scale, that you have to find out. Anyway, so this is the procedure to take this reading from this scale. So, this after taking this reading you have to note down, okay. You have to note down, fine. So, this is the initial reading. So, without applying any mass, what is the initial reading? So, that we have to note down, and then I will apply mass. So, I have mass here, this all are 500 gram. So, we have 6 mass here. So, each are having this 500 gram, So, we will just put one mass first, this the 500 gram. Okay. So, this is the 500 gram. Okay. So, now I have to take again reading. Okay. So, you see this crosswire, this is not now coinciding, it has gone up. So, basically this depression is downwards, but in microscope we see this vertical image. So, as if it has gone this cross position has gone up. So, I have to take basically this microscope that is slightly up. So, I can use this very fine movement using this one. So, that is what I have to do. Yes, no, if I put this way, then actually I am taking down, but image is going up. So, that is why, yes, it is now coincide. Okay. Then again you have to take reading, main scale reading and vernier scale reading. So, then note down that one. Okay. So, then I will go for next mass, and put there. So, now it is 1000 gram, means 1 kg. So, for that again I have to move it to coincide with this indicator here, this cross position, and we will take the reading from main scale and vernier scale. So, this way we just increase the mass, again this it is for 1.5 kg, then again you have to take reading. So, this way for at least for 5 to 6 mass we will measure the depression. So, we will have 5 to 6 reading, means mass this load versus depression. So, for each load what is the depression. So, that table we have to make, means this for different load, different mass. So, from here we have taken whatever the reading. So, now from that reading you have to do some calculation, and then for 500 gram what is the depression. So, you have to take basically difference between these two reading. So, always you have to minus this initial reading from this your reading when you applied mass. So, that way for different mass you will get the depression. So, your table is ready now for different mass or load, what are the depression. Now, this next work will be the plotting of the graph of these two, mass versus or load versus this depression. Okay. So, you plot depression in y axis and mass or load at along the x axis, and then from there basically you will get a straight line, and from that straight line your we can find out, calculate the gradient or slope of this straight line, and from that slope basically we will use the slope to calculate the Young modulus. So, that how to make table and how to calculate the Young modulus, that I will discuss in details in next class. Okay. So, I will stop here. So, I think this is the live demonstration of this experiment, as well as also we will discuss about the other experiments. I think we will try to show you all experiments in our laboratory, and that will be useful for you. So, thank you for your attention.